Next is the geology and the PGE mineralization of the Sunju Lake intrusions. Although its exposed strike length is only 3 kilometers, the SLI or the Sunju Lake intrusion has a distinctive aeromagnetic signature that can be traced for at least 20 kilometers beneath the cover of glacial drift. The nearly constant width of its aeromagnetic anomaly suggests that intrusive sheets retains a fairly uniform thickness. Eastern margin of the SLI is abruptly truncated or cut by the Beaver River diabase dikes. That is represented by the color blue-green in this figure. For your base, intrusive contact with a complex mixture of gabbroic to dioritic rocks, granophyre, and volcanic hornfels. And your top, in gradational contact with the granophyric quartz, ferromonzodiorite phase of the Finland granite. The SLI is predominantly composed of well-laminated mafic mesocumulates that define the unidirectional or unidirectional differentiated sequence. And you have here two zones, the lower contact zones and the upper zone. Your lower contact zone is fine-grained melatroctolite cumulates, or represented by SLMT, your OP cumulate. And your upper zone is unlaminated olivine ferromonzodiorite, or your SLMD. So as you can see here in this figure, the geology of the Sunju Lake intrusion, between your lower contact zone, that is represented by an army green color, which is a melatroctolite cumulates, and your upper zone, represented by a color orange. Looking at this picture, we can see 5 units that are distinguished on basis of cumulus mineral as assemblage. These are the units or ascending order of units. Your SLD is your dunite, your SLT is your troctolite, SLG, gabbro, SLFG is your ferrogabbro, SLAD, your apatite olivine ferrodiorite. This cumulus stratigraphy is complemented by a smooth cryptic variation in mineral composition. Miller and Ripley of 1996 calculated the bulk composition of the SLI by a weighted sum of its chemostratigraphy and demonstrated a good fit to fractional crystallization models that this composition is a reasonable estimate of apparent magma. So this is the weighted sum that Miller and Ripley calculated, specifically the first column or your column 1. And these are the models. The unidirectional cumulus stratigraphy and smooth cryptic variation suggest that the SLI is formed by fractional crystallization under nearly closed conditions. Actually, they thought of the cumulate paragenesis and cryptic layering of the SLI is remarkably similar to the classic Skiergård intrusion. This figure is a stratigraphic variation in measured mineral mode. So your A figure is the average cumulus mineral mode. Your B is your magnesium number of olivine, forestite, and augite, your enstatite. C is the ratios of incompatible trace elements. Your D are your trace elements such as outcrops and real core samples profiling the SLI. So, as you observe in the model B and C, it results to chaos 2, right? The chaos 2 means that there is a fractional crystallization, or there is a separation of liquid and crystals happening in this area. Dayton on 2011 conducted an ND or neodymium, HF, hafnium, and PB led isotopic analysis of the SLI and the overlying Finland granite to evaluate the extent of contamination between the granite and the SLI parent magma. In Dayton's study, the data indicated that contamination is nominal or low, around less than 2%, and this is evident in the SLI from about the onset of apatite crystallization. Given this table as an evidence, also, the isotope data seem to indicate that the quartz ferromonzodiorite unit assigned to the Finland granite may actually be contaminated upper differentiate of the SLI, comprising approximately 51% of the total SLI stratigraphy. And then Dayton recalculated the bulk composition using additional whole rock analysis. Calculating out the contamination contributed from the Finland granite, that is 1 to 2% of the total SLI, and assuming two different upper contacts to the SLI, your SLMD unit found in this table, column 2, and the 5% of the FRQM unit, which is found in the next column, your column 3. Bird et al. Of 1991 and Anderson et al. Of 1998 discover the AU, or your gold to palladium rich Plantenova Rift, in the middle zone of the Skiergård intrusions. So earlier, I said that Miller and Ripley thought that the SLI is similar to the Skiergård intrusion. So there is this question that arose in connection to the discovery of gold palladium rich Plantenova Rift. The question is to whether a similar stratiform PGE rift may occur in the SLI. When a review of a whole rock data was evaluated, it was discovered that copper concentrations dramatically increased from 100 ppm to over 600 ppm in the SLFG unit, approximately 2/3 up in the intrusions. So, meaning, with this result, it implies that sulfide saturation had been attained at the level in the intrusion. And also, an orthomagmatic PGE reef similar to Plantenova may indeed have formed in the SLI. Geochemical sampling study subsequently undertaken wherein 67 outcrops and drill core samples was analyzed for platinum, palladium, gold, sulfur, copper, and other major elements. This data here reveals that indeed a PGE enriched interval exists within the FG unit and lies immediately below the abrupt increase in copper. Also, it shows that nickel was strongly depleted in the magma at the infrared sulfide saturation by prolonged olivine crystallization. And by the way, this results published in Minnesota Geological Survey information. Josh Lin of 2004 studied the petrography and geochemistry with the goal of better defining the mineralization and understanding its origin. Detailed geochemical assays of the core revealed that the precious metal mineralization occurs over an 85 meters thick interval within homogeneous, well-foliated oxide gabbro. Referred to this interval as the precious metal zone, or your PMZ. This figure shows a strong narrow of your gold peak that is associated with a drop jump of copper. Below the copper to gold break, your palladium and platinum are broadly offset, with palladium below platinum. And as you can see, it also shows several subzones of enrichment. By the way, above your copper to gold break, all your precious metals are strongly depleted in that area. The spatial relationship of PGE zonation, sulfide distribution, and subtle model layering of cumulus silicate phases strongly suggest that the PMC formed by the orthomagnetic process of sulfide liquation and fractionation from silicate magma. When directly comparing to Sunju Lake intrusions and your Skigard intrusions, not only are their petrologic similar evident, but also their patterns of precious metal mineralization. As you can see, both of their parent magmas are initially sulfide undersaturated and became saturated at proportionally similar levels in their crystallization histories. Also, both intrusions are crystallizing a cumulus mineral assemblages of plagic clays, augite, and iron oxide at the time of sulfide saturation. Both also show peak PGE concentration at or below the level of initial sulfide saturation, which is marked by an abrupt increase in copper and increase in sulfur above 400 ppm. And another part of the evidence is that both show low and variable levels of palladium in lower sulfide, undersaturated, part of the intrusions, and complete and persistent palladium depletion above the sulfide saturation horizon. Lastly, both of the Sunju Lake intrusion and the Skirgard intrusion show an upward displacement of your peak gold or your gold peak concentration from the palladium peak. So based on the data gathered and the evidences that are being provided, researchers strongly prove that your Sunju Lake intrusions is classically similar to the Skirgard intrusion.